The last part of this stoichiometric lecture is on limiting reagents and reaction yield. So what are limiting and excess reactants? So class yung reagents, parehas lang yun sa reactants, no? It's just another word for reactants. So imagine, ayan, we have burger patties, burger buns, cheese, and tomatoes right here. And gumagawa tayo ng burgers, ayun. So basically, ang isang burger dapat may laman na patty, na bun, na cheese, and tomatoes, ayan. So as you can see, if you have 4 buns right here and you only have 3 patties, you can't make 4 burgers. You can only make 3 burgers. So this class is just the concept of limiting and excess. Yung limiting reactant natin or yung limiting material natin or limiting reagent is the material na mabilis mauubos. And the excess reactant is, or the excess material is the material that is in excess o sobra pagkatapos ng reaction. So in this example, the limiting reactant will be the burger patty. Kasi kaunti lang siya, so mas mabilis siyang naubos. And yung ating excess reactant will be your cheese and your tomatoes and your buns. Kasi after you made the burger, sila yung natira. So an important concept to note is that the reaction, in a reaction, the maximum number of products that will be produced is nakadepende doon sa ating limiting reactant. Kasi by the time na maubos siya, tapos na yung reaction. So it's as easy as that. So as I was saying a while ago, a limiting reagent or reactant is the reactant that is consumed first in a chemical reaction. Siya yung unang nauubos. It is called a limiting reactant because it limits the extent of a chemical reaction. So, nililimit niya, no, yung progress yung extent ng ating chemical reaction. By the time na maubos siya, tapos na yung reaction. And the maximum amount of product formed will depend on the limiting reagent that was originally present. Kasi again, pag naubos na siya, tapos na yung ating reaction. Now, what are excess reagents? These are reactants in a chemical reaction with a greater amount than necessary to react completely with the limiting reactant. Sa madaling sabi, masyado siyang marami, no? It is the reactants that remain after a chemical reaction has reached equilibrium. So, siya yung natitira pag natapos na yung ating chemical reaction or na-reach na ng ating reaction yung state of equilibrium. So, what are the steps in determining the limiting reactant? I'll try to give you more simpler steps, no? So the steps in determining the limiting reactant, LR is limiting reactant. Step 1, convert everything to moles. Convert everything to mole. Kapag mole na yung binigay sa problem, wala na kayong i-convert. Kung nakagram siya, convert everything to mole. How will you identify the limiting reactant? The smallest mole, it is the limiting reactant. Whenever you solve problems for limiting and excess, the first thing that you have to do is to determine first who is the limiting reactant. Why? Kung sino yung limiting reactant mo, siya na yung gagamitin mo kasi sa lahat ng calculation. So, kailangan ma-identify mo muna siya before you start calculating. Okay lang. Ganun lang siya, class. It's as easy as that. Okay? So, let's try solving this problem. So, you have ammonia reacting with oxygen to form nitrogen oxide and water. So, again, bago ka mag-solve, hindi ka muna basta-basta magsosolve. I-check mo muna kung balance yung equation. That is why I keep on emphasizing that you really need to practice on balancing equations. Now, how do we check if the equation is balanced? First step, enumerate the elements on both sides of the equation. So you have nitrogen, hydrogen, and oxygen on both sides. Next, count the number of atoms. So, okay, some students would say, Miss, ano po yung number of atoms? Again, the number of atoms is the subscript, no? So, si nitrogen dito sa ating reactant side. So, again, this is your reactant. And this is your product. Ayan. So, si nitrogen, ilan ang number of atoms niya dito? 1 lang. Pag wala pong subscript, automatic 1 yun. Hydrogen is 3, oxygen is 2. Nitrogen is 1 in the product side. Hydrogen is 2. Let me rewrite that. Ayan. Hydrogen is 2. Oxygen is 1 plus 1. It's also 2. Is the equation balanced? No, it's not. So you cannot answer the problem kasi it's not yet balanced. So we have to balance it first. So once you have counted the number of atoms, the next step is to multiply it with a whole number to make it balance. So again, yung tip ko during the balancing chemical equations video, you start with elements na once lang na isulat on both sides of the equation. What do I mean by that? Nitrogen is only written once at the reactant side. Same in the product side. Hydrogen is written once on the reactant side. Also written once in the product side. Oxygen is written once in the reactant side. And it is written twice on the product side. So, hindi muna natin gagalawin si oxygen. Huwag nyo munang gagalawin yon. Ang gagalawin ninyo lagi is yung written once on both sides of the equation muna. Okay, class? So, let's start. As you can see, nitrogen is already balanced. It's 1 and 1. So, how do you balance hydrogen? Multiply it with a number to make it equal. So, in this case, if I multiply this by 2 and I multiply this by 3, they will be equivalent to 6. Kung ano po yung number na pinang-multiply natin, yun po yung magiging coefficient. So, dito sa reactant side, nag-multiply tayo ng 2, maglalagay tayo ng coefficient na 2. Hindi mo yan ilalagay dyan sa gitna. Kasi, isang compound si ammonia. So, dapat dito siya. Next, this one, we multiplied it by 3. So, you have to write here 3. Now, once you have written it, nadidistribute yung coefficient. So, in this case, kung originally 1 lang si nitrogen, 2 times 1, this will become 2. And here, 3 times 1, it's now 3. Tatlo na yung ating oxygen dito. May isa pa dito. So, 3 plus 1, 4 na yung oxygen dito sa product side. Okay. The next step is to balance the nitrogen. Let's balance first the nitrogen. So, dalawa na dito sa reactant. Dito sa product side, isa pa lang. So, multiply this by 2 to become 2. If you multiply this by 2, maglalagay ka dito ng coefficient na 2. So, 2 times 1 is 2 and 3 times 1 is 3. So, this is how much? You now have 5, right? You now have 5. Now, class, it's difficult to balance equations na odd and even numbers. So, whenever you encounter things like this, what you have to do is to start from the beginning and try to double your coefficients. What do I mean by that? You make this 4, you make this 4, you make this 6. Okay? So, tanggalin natin muna lahat. Ayan, not that one. Tanggalin natin yung mga pinang-multiply natin. Ayan. Class, balancing chemical equations is a matter of trial and error. Sometimes you don't get it once, such as in this case. Kapag ganun nga, what you do is you double your coefficients. So here, ilan? Dalawa, and here, isa ulit. Now, we start from the very beginning. We double our coefficients. Kanina, ang coefficient nito ay 2. Gagawin natin siyang 4. If you make this a 4, this becomes times 4. It's equal to 4. And 4 times 3, this is now equal to 12. Now class, how will you make this a 4? You multiply this again by 4. So since you multiplied by 4, you write here a coefficient. You write there a coefficient of 4. And you distribute again. So 4 times 1, 1 atom of oxygen, that's 4 plus 1. This is now 5. Now class, how do you balance 12 and 2? If you multiply this by 6, this becomes 12. So you write here 6 kasi nag-multiply ka ng 6. So 6 times 2 is 12. 6 times 1 atom of oxygen is 6. Tapos 4 times 1 atom of oxygen is 4. So 6 plus 4, your oxygen now here is 10. You have 10 atoms of oxygen here. Now, you can now multiply, you can now balance the oxygen here kasi parehas na silang even number, no? So, 2 times 5 will give you 10 atoms of oxygen as well. So, this is now your balanced chemical equation. Again, if you don't get it the first try, what you have to do is to double your coefficients. It's as easy as that. So, class, ganun siya. Mag-practice kayo mag-balance. Hindi kayo makakapag-solve ng problems unless balance na yung mga equations ninyo. So, let me rewrite that equation again here below para mas mabilis natin siyang ma-access kasi magsosolve na tayo. Once you have balanced the chemical equation, it's now time to solve. So, in this problem, okay, let me write the coefficients here. 4, 5, 4, and 6. So, in this problem, sabi niya, in an experiment, 3.25 grams of ammonia are allowed to react with 3.5 grams of oxygen. So, sa isang experiment daw, yung meron ka daw 3.25 grams ng ammonia, nag-react daw with 3.50 grams of oxygen. The first question is, which is the limiting reagent? Reagent and reactant class, parehas lang yan. So, ano yung sabi ko? I-identify mo yung limiting reactant. Paano? Ito ay 3.25 grams. Ito ay 3.50 grams. Sabi ko, the step is to convert everything to mole. That's the first step. O, i-convert mo muna lahat yan to mole. So, let's first convert 3.25 grams of ammonia. We convert that to mole. How do you convert it to mole? You use the conversion factor. 1 mole of any substance, which in this case is ammonia, it's equal to its molecular mass, which is 14.01 plus 3.03. That would be 17.04 grams. Okay? So, you can now solve. Sa baba yung grams, 17.04. Sa taas, 1 mole of ammonia. O yan, may mga magtatanong ulit, saan po galing yung 17.04 grams? That's the molecular weight of ammonia. Where do you get the molecular weight? You get the sum, no? The sum of the sum of atomic weights in the periodic table. If you still haven't figured out how to get the molecular weight, please watch our lecture on how to get the molecular mass of your compounds. So, once you input this in your calculator, so you have 3.25 divided by 17.04, the answer will be 0.191 mole of ammonia. Tapos na po ba? Hindi pa po. Iko-convert mo din yung grams nung isa, which is oxygen. Now, you convert 3.50 grams of O2 to mole. What conversion factor will you use? 1 mole of oxygen, O2, is equal to 32.00 grams. Saan galing yung 32 grams? Sa periodic table po. So, sa baba, yung grams again, para mag-cancel yung units. So, this will cancel. So, 3.50 divided by 32.00, the answer is 0.109 mole of oxygen. Now, how do you identify who is the limiting reactant? Na-convert mo na lahat eh. Again, the smallest mole is the limiting reactant or reagent. So, the limiting reactant here is oxygen. This is your limiting reactant. So, ano yung isa? Kung limiting na to, ito yung iyong excess reactant. So, ammonia is your excess reactant. So, excess is ammonia. Your limiting is oxygen. Okay? So, the limiting reactant is oxygen. The excess reactant is ammonia. Now, let us answer number 2. How many grams of nitrogen oxide are formed? Kanina, sabi ko sa inyo, mahalagang ma-identify kung sino yung limiting reactant. Kasi once you compute for any problem, ang gagamitin nyo na is the mole of the limiting reactant. Kaya dapat talaga makuha mo muna yung mole ng limiting reactant. So, sa letter B, so this is letter A. Sa letter B, ang tinatanong sa atin is grams ng nitrogen oxide. Okay, balikan natin yung problem. So, kung meron kang 3.25 grams ng ammonia at 3.50 grams ng oxygen, ang tinatanong niya, ilang grams daw nitong nitrogen oxide ang mafo-formed? Okay. Paano ka magsisimula? Class, kaya nga ang first step is identifying the limiting reactant. Kasi yung mole ng limiting reactant, yun na lagi ang gagamitin mo. So, magsisimula ka, ang gagamitin mong value is the 0.109 mole of oxygen. Iko-convert mo ito sa grams ng nitrogen oxide. O mag-strategize muna kayo again. So, paano ka makakarating ng grams ng nitrogen oxide from the mole of oxygen? Sabihin natin again, this is compound A and this is your compound B. You have two conversion factors. The 1 mole of any substance is equal to its molecular mass in grams, and the second one is the mole of any substance is equal to the mole of another substance. Again, ginagamit mo tong first conversion factor kapag same yung compound. Ibig sabihin, from mole ni A, gusto mong makuha yung gram ni A. Kapag itong second conversion factor, kapag different yung compounds, ibig sabihin, yung mole ni B, gusto mong i-convert to mole ni A or vice versa. Okay? So, let's start. Ang starting mong unit is mole. So, from mole ni A, ayan, compound A natin is oxygen, gusto mong makuha yung grams ni compound B. However, wala tayong straightforward na mole ni A papunta sa grams ni B. Kailangan mole ni A papunta sa grams ni A. So, look at the common units again. The common unit here is mole. So, gawin mo muna tong mole ni B. Pag nasa mole ka na ni B, pwede mo nang makuha yung grams kasi from mole ni B, papunta sa gram ni B. You can do that now because it's now the same compound. So, the next step is to write the conversion factors. The conversion factor would be mole ni A. What is your compound A? It's oxygen. It's equal to mole ni B. What's your compound B? It is nitrogen oxide. Now, look at, whenever you use the mole-to-mole conversion factor, you look at your balanced chemical equation and you look at the coefficients. So, kaninong coefficient yung titingnan natin? Kay oxygen and kay nitrogen oxide. Oxygen is 5. Nitrogen oxide is 4. So, oxygen is 5. Nitrogen oxide is 4. So, that's your first conversion factor. Next, mole ni B, gram ni B, you use this first conversion factor. So, 1 mole of, what's your compound B? It's nitrogen oxide. Nitrogen oxide is equal to 30.01 grams. Saan po galing yung 30.01 grams? This is the sum of your atomic weights na makikita natin sa ating periodic table. Now that you have the complete set of the conversion factors that you will be using, it's now time to solve. Where do you begin? You always begin with the mole of your limiting reactant, which is 0.109 mole. So, 0.109 mole of what compound is that? Do not forget kung sino yung may-ari ng mole na yon. 0.109 mole of oxygen. So, you have two conversion factors, so you'll have two parentheses here. Sa baba, the first parenthesis will contain the first conversion factor. Sa ating denominator, we'll have 5 moles of oxygen. Sa taas, we'll have 4 moles of nitrogen oxide. Nasa baba, yung mole ni oxygen para mag-cancel. The next parenthesis will contain your second conversion factor. So, sa baba, yung mole ng nitrogen oxide. Sa taas, 30.01 grams. So, if you input this in your calculator, 0.109 times 4 divided by 5 times 31.01 divided by 1, the answer is 2.62 grams of nitrogen oxide. So that means, class, that if these two compounds react, they will form 2.62 grams of your nitrogen oxide. Okay? So, pag nag-react sila, completely mauubos tong 3.50 grams kasi siya yung limiting reactant. Pero dito sa ammonia, may matitira. Okay? So, I hope this is clear. Now, we go to the next question. Letter C. The next question is, how much of the excess reactant remains in grams after the reaction? How much of the excess reactant remains in grams after the reaction? By the way, class, before I proceed to the, to the next problem, take note that this is your theoretical yield. Theoretical yield. Yung theoretical yield, later I will discuss this, no, kung ano yung theoretical yield. But basically, kinocompute mo yung maximum grams ng product na mafo-form. So, yun yung iyong theoretical yield. Okay, balikan ko yung letter C. Ang hinahanap niya dito sa letter C is ilan daw excess reactant yung matitira after ng reaction. Ang hinahanap nating, class, ay matitira. Yung matitira. Sino yung excess reactant mo? Ito ang excess reactant mo. Ang limiting reactant mo, itong si oxygen. So, class, ganun pa din. Gagamitin nyo pa din yung moles ni, moles ni limiting reactant. Class, ang una ninyong mako-compute pag hinahanap yung excess, the first thing that you can compute, that you will compute when they are looking for the remaining excess reactants, yung natira, ibig sabihin, nag-react na silang dalawa, ilan yung natira? Ang una yung mako-compute is kung ilan yung nagamit, ilan yung nag-react kay oxygen. Okay? So, the excess reactant is ammonia. So, kunin mo muna yung grams ni ammonia. That's your first step. Get first the grams of your ammonia. Saan ka magsisimula? Gagamitin mo ulit yung mole na na-compute mo sa limiting reactant mo. So, this is 0.109 mole of your oxygen. Kailangan makarating ka sa grams ng ammonia. Bakit sa grams ng ammonia? Kasi excess reactant yung pinapahanap sa'yo, no? Yung natitirang excess reactant. Pero hindi pa natin mako-compute ngayon yung natitira. Ang mako-compute pa lang natin dito sa first step is kung ilan yung magagamit. So, step 1, compute or calculate how much is consumed or the amount consumed by the limiting reactant during the course of the reaction. So, gawa muna tayo ulit ng map, ng outline, paano tayo makakarating sa grams ni ammonia. Again, this is compound A and this is your compound B. You have two conversion factors. 1 mole of any substance is equal to its molecular mass in grams, and the other is mole of one substance is equal to the mole of another substance. Again, ginagamit mo itong una kapag same yung compound. Dito, if you want to jump from one compound to another, so magkaibang compounds. So, the starting unit is mole of oxygen or mole of A. Siya yung ating compound A. Paano ka makakarating ng gram ng compound B. Hindi mo pwedeng gamitin tong unang conversion factor again. Bakit? Kasi you use this kapag gusto mong mole ni A, gagawin mong gram ni A. Kailangan same yung compound. So, the best thing to do is if you want to jump from one compound to another is to use the mole-to-mole conversion factor. So, mole ni A, gawin mo munang mole ni B. Kapag mole na siya ni B, kapag mole na siya ni B, same compound, you can now convert it to the gram of B. So, you can now convert it to the gram of B. Next step, write the conversion factors. So, mole of A, so what is our compound A? It is oxygen. It's equal to the mole of compound B, which is ammonia. Whenever you use the mole-to-mole conversion factor, you always refer to the balanced chemical equation. Titingnan mo yung coefficients. So, tingnan natin yung coefficient ni oxygen and ni ammonia. So, oxygen class is 5, ammonia is 4. So, write that here. Oxygen is 5, ammonia is 4. The second conversion factor, so mole to gram, ito yung gagamitin natin. So, 1 mole of compound B, which is your ammonia, is equal to its molecular mass, which is 17.04 grams. Can you now solve? Yes, because you have now the complete set of conversion factors that you will need in order to achieve the desired unit. Saan ka magsisimula? You always use the calculated mole of your limiting reactant. Yung na-calculate natin during the first step. So that is 0.109 mole of your oxygen. So you have two conversion factors. So we'll have two parentheses here. So, sa baba, mole ni oxygen. Bakit po? Para mag-cancel. Sa taas, mole ng ating ammonia. Dito sa baba, sa denominator, sa second parenthesis, mole ni ammonia para mag-cancel. Sa taas, yung ating desired unit na grams. So, if you input that in your calculator, so 0.109 times 4 divided by 5 times 17.04 divided by 1, the answer would be 1.49 grams of ammonia. Class, kung ang tinatanong sa problem is how much is consumed, this is already the answer. However, ang hinahanap sa inyo is yung natira after the reaction. Itong na-compute natin, this is the consumed. Ibig sabihin, yung 3.5 grams ng ating oxygen, ang naubos niya, nakipag-react siya with ammonia, ang nakonsumo niya is 1.49 grams. How do you get the remaining? Madali lang, class. How do you get the remaining excess reactant? Isusubtract lang natin. So, kung initially, bago nag-start yung reaction, meron kang 3.25 grams ng ammonia mo, tapos ang nakonsumo sa reaction ay ito, 1.49 grams ng ammonia mo, i-minus mo lang yan, Get the difference. So, 3.25 minus 1.49, the answer is 1.76 grams of ammonia. So, nung natapos yung entire reaction at nag-form na tayo ng ating products, may natira tayong 1.76 grams ng ammonia. Asan yung oxygen? Ubus na siya. Kasi siya yung ating limiting reactant. So, I know medyo matrabaho kung paano isolve itong si limiting and excess. But it's just a matter of practice, Sanayan lang din talaga yan. Hindi pa tapos ang ating lecture. We're going to discuss reaction yield or percent yield, So, percent yield is the percent yield of a chemical reaction. This is the percent ratio of the actual yield to the theoretical yield. It is calculated using this formula. So, isulat muna natin yung formula. So, pag percent yield, that is equal to the actual yield over the theoretical yield times 100. Okay, what's important here is this. The theoretical yield is always calculated by the analyst. calculated by the student who is doing the experiment. So in this case, kinalculate natin yung ating theoretical yield kanina, which is 2.62. Anong ibig sabihin ng theoretical yield, class? Yung theoretical yield, ayan, lakihan ko lang to. The theoretical yield of the chemical reaction is the amount of product that would result if all the limiting reagent reacted. So, ibig sabihin, class, kung totoo talagang if, the scenario is, you'll get the theoretical yield if the whole 3.5 grams na limiting reactant would completely react with your ammonia. Ibig sabihin, lahat talaga yon, yung 3.5 gram na yon, magre-react sa iyong ammonia. Yung actual yield, on the other hand, is the amount of product that was actually obtained from a chemical reaction. I know this is kind of tricky because we're not doing this in the laboratory. Pero kasi sa laboratory, yung actual yield, ito yung tinitimbang mo pagkatapos ng experiment. Yung theoretical yield, makocompute mo kasi initially, ikaw yung nagtimpla, alam mo kung gaano kadami yung hinalo mo, so makocompute mo talaga siya. So theoretically, kung magre-react lahat ng starting reactants mo, ganun kadami ng products yung ma-obtain mo, theoretically. However, in the laboratory, it's not always true. So, kung ang computed ko sa laboratory is 2.62 grams, yun yung theoretical yield ko. Pag nagtimbang ako after the reaction, hindi ko makukuha yung buong 2.62 grams. Usually, ang makukuha ko dyan, 2 grams, 1.75 grams, depende sa course ng reaction. Bakit? Kasi, in real life, hindi lang naman yung starting materials mo yung nagre-react. What do I mean by that? Sino ba ang starting materials mo dito? Si oxygen and si ammonia. In real life, hindi naman magre-react yung dalawang yan completely. There will be contaminants in the reaction, no? There will be contaminants. Say for example, hindi mo nalinis ng maayos yung glasswares mo, there might be metals that will be reacting with your starting material. So, hindi mo makukuha yung buong 2.62 grams. You will always get less than of your theoretical yield. Kaya walang 100% yield. You will never get 100% yield because not all your starting materials will completely react with each other. Now, class, since you are not doing this inside the lab, ito ang tip. Ang theoretical yield ko, computein mo. Ang actual yield laging binibigay sa problem. The actual yield is always given because you are not doing this in the laboratory. But if you are doing the experiment, yung actual yield, yun yung tinitimbang pagkatapos ng experiment. Okay? So, I've already mentioned this, no? Walang nakakakuha ng 100% yield. Sobrang galing mo na if you get 100% yield, no? Because the limiting reactant is not always fully consumed in most chemical reactions. Okay, let's answer letter D. Ayan. So, the question here in letter D is, what is the percent yield of the reaction if only 2.13 grams of nitrogen oxide was produced? So, ano tong 2.13 grams ng nitrogen oxide? Class, this 2.13 grams of nitrogen oxide, this is the actual yield. Sabi ko nga sa inyo, kung hindi kayo yung nag-experiment, the actual yield will always be given in the problem. So, what's the formula? This is the formula for percent yield. So, percent yield is equal to your actual yield, which is 2.13 grams, over your theoretical yield. Yung theoretical yield, wag mong hanapin sa problem yan kasi ikaw ang magko-compute niyan. Ayan. That's the maximum amount of products that will be formed. It is 2.62 grams. So, the theoretical yield here is 2.62 grams. Multiply it by 100. The percent yield will be equal to 2.13 divided by 2.62. And times 100. It is now equal to 81.30%. What does that mean? Ibig sabihin, 81.30% lang ng ating limiting reactants or ng ating starting materials ang nag-react to form our products. So, it's as easy as that. Madali lang talaga siya. Medyo matrabaho lang. It's just a matter of practice, no? So, practice in solving para gumaling tayo sa pagko-compute. So, take a screenshot of this problem. Your lesson facilitator will solve this together with you once you conduct your synchronous sessions. And this one as well. So, that's it. That ends your discussion in stoichiometry.